Energy and its forms. In this lesson, we're going to be covering energy in life. We're going to be answering the question, where does energy come from? And then we're going to be discussing the 9 main types of energy, including thermal, electrical, radiant, nuclear potential, gravitational potential, kinetic, elastic potential, sound, and chemical potential. Energy equals life. Energy powers our planet. Without the energy from the sun, all life would perish. Plants require energy to produce the life-sustaining sugars all living things require, and energy from the sun keeps our planet warm. Without energy from the sun, life on Earth couldn't exist. Energy also equals convenience and comfort. We use energy every day to heat our homes, run our cars, and power our gadgets. Just imagine what life would be like without it. So where does energy come from? So we obtain our energy from many sources. We get it from the wind, solar, nuclear, fossil fuels, geothermal, and lots of other ones. Now when we say where do we get our energy from, it's pretty much what we're talking about is where do we harness it from. It's not like we're making this energy, we're simply obtaining it from different sources. In this case, we're generally going to create electricity from wind energy or solar energy or fossil fuel or nuclear, etc. Types of energy. There are many forms energy can take, but we're going to discuss the main 9 kinds. So before we get started, I want you to pause the video and list as many main types of energy as you can think of. An example to get you started is electricity. Electricity is a type of energy. Number 1, thermal energy. Thermal energy is the energy of a substance due to the motion or vibration of its atoms. An increase in molecular motion is going to equal an increase in temperature, and it's usually associated with heat energy. Thermal energy is produced through friction, i.e. rubbing your hands together generates heat through friction. Now I have 2 pictures here. The first one on the left is showing how this block of metal is being heated up. Now in this case, what's happening is that the molecules inside the metal are moving faster, giving it a higher temperature, and thus changing its color. Another example of that is this zoomed in version here on the right hand side. Now you can see all the little circles, they have arrows on. Those arrows represent the speed of the molecules. As we increase the energy, as we go from left to right, we see the arrows get bigger. This increase in the size of the arrows represents an increase in their velocity, which is representative of an increase in temperature. So increase speed or velocity equals an increase in temperature. So when we're saying it's warm outside today, we're simply saying that the molecules outside are moving faster than they would otherwise be doing, which doesn't have quite the same ring to it. Electrical energy. Number 2, electrical energy. Electrical energy is the energy carried by electrons moving from one substance to another. So for example, electrical circuits to power your phone and lightning. These are both examples of electrical energy. We're simply getting the electrons jumping from one spot or moving from one spot to another. Now, certain materials allow the electrons to move better than others, and that's where you're going to get things like conductors. So you get things like metal conductors, aluminum, copper. They're very good conductors of electricity because they allow electrons to flow freely between them. Number 3, radiant energy. Radiant energy is the energy carried by waves in the electromagnetic spectrum. So for instance, microwaves, visible rays, radio waves, gamma rays, all these waves that make up the entire electromagnetic spectrum. And what they do is that they move from one place to another and they carry energy with them. So the energy is moved from point 1 to point 2. If it's carrying light waves, it's going to move light from one place to another. Microwaves transfer energy from the actual emitter into your food, heating up the molecules in your food, making it warmer. Number 4, nuclear potential energy. Nuclear potential energy is the energy stored in the nucleus of an atom, and we all know how damaging that can be. Things like nuclear bombs, nuclear reactors, all utilize this to create energy. Now there's 2 differences between these 2. Nuclear bombs is actually called a fission reaction. That's when you're taking 2 molecules and making them into one. A fission reaction is when you're taking 1 molecule and making it into 2 different molecules. And that's what we use. So our power plants right now are going to use fission reactions to create a lot of energy. Now the amount of energy created is significantly higher in fusion reactions compared to fission reactions. Much, much bigger. But right now we're not at a point where we can utilize fusion reactions in order to create energy safely and efficiently. Number 5, gravitational potential energy. If you raise an object above the ground, you give it potential energy. Water that's raised up gains potential energy due to its motion against gravity as gravity wants to pull it down. You need energy to move that water up, so that energy generally comes from the sun. So the sun is going to, say in this picture on the bottom right hand, is going to shine, and it's going to shine on this water down here, and that's going to give the water energy. That water then gains enough energy to go up into the clouds and then eventually fall back down here. So it's not like we're creating energy. We're using the energy from the sun, we're transferring that energy from the sun to the water. That water gains energy, it then goes up into the clouds because it's moving faster, and then it comes down into the higher area. Then what we're going to do is we're going to trap that water up top here, and we're going to let it flow down in a way that we want it to. When it flows down, it's going to go through these things called penstocks, which causes these, they're almost like fan blades, they're called turbines, to spin. So if you think of the penstock as kind of like a little area for the water to go down. And when this water goes down, it's going to hit these fan blades. So they're kind of like that. And this is a very simplistic version, obviously. When it hits the fan blade, it causes the fan blades to spin. As the fan blades spin, This causes the generators on the left here to spin, creating our electricity. After the water has done its job, turning the turbines, it flows out, and it comes out in this section right here. And then it can be raised back up, and so on, and we can repeat the process over and over and over again. Again, we're not creating energy, we're utilizing energy from the sun. Number 6, kinetic energy. Kinetic energy is the energy of motion. If something is moving, it has kinetic energy. Now, for instance, if an object is at the bottom of a hill and it's moving at a good pace, let's say 10 meters per second, and then without applying any more gas, it hits this hill and goes up and up and up and up. As it goes up, it's going to slow down. Maybe here it's going to be 5 meters per second. And then at the very top, it's going to be 1 meters per second. And this is an excellent example of an energy transformation. As that object then descends back down the hill, it's going to gain its speed up again. And so its kinetic energy is going to increase as it goes down the hill. So kinetic energy is the energy of motion. More motion, more energy. Number 7, elastic potential energy. This is the potential energy that is stored in objects that are stretched or compressed. So for instance, a bow and arrow. These objects will transfer their stored energy as they go back to their original position. Now, where is the energy stored? A lot of people think the energy is actually stored in the string here, but it's not. The energy is stored in the bow, because when this person pulls back the string, she bends the bow from more of a straight up and down to this curve that you see in the actual bow. As she does that, she stores energy in the actual bow itself. When she releases the string, the energy is transferred from the bow to the arrow, giving the arrow kinetic energy. This is also seen in things like elastic bands, where you can stretch an elastic band and then it'll want to go back to its original spot. If you let that elastic band hit something, it can actually do work. It can release that energy that's stored in the elastic band when you stretch it, and it can be used to do something else. Sound energy, a type of energy that is produced by vibrations. Now, sound energy travels by waves through materials such as air or water. It's similar to electromagnetic radiation, but a little bit different. Electromagnetic radiation is going to use things like light waves, gamma rays, radio waves. Sound waves look very similar, and in fact, this is an example of a sound wave, but you could also think of a sound wave as something like that. So it's going to look a lot like our electromagnetic radiation, but it's a little different. And number 9, chemical potential energy. This is energy that is released when atomic bonds are created and is absorbed when bonds break. So a good example of this is when methane chemically reacts with oxygen in the air, there's a net release of energy. And you can see here with our burner, the methane is going to be coming out of these little holes, and it's going to be ignited, and when it is, it's going to give off heat and color. Also, batteries store chemical energy, and this chemical energy can be used to do things like power our electronics as the chemicals are reacted to each other and allowed to release their energy. Energy units. So what unit are we going to use when we're talking about any energy problem? Well, that's going to be the joule, simply stated as J. Now, if you have 1,000 joules, you're going to get 1 kilojoule. And oftentimes you'll see information given in kilojoules, and you'll need to convert it to joules to get your answer. Energy transformation. So we've talked about moving from one energy form to the other. We use the example of the EK, so kinetic energy, into potential energy as the car went up the hill. And then as the car went back down the hill, it got transferred back to kinetic energy. Right, so it was like this. Right, we already talked about that example. That is an example of energy transformation. Energy is transferred from one form, kinetic energy, to another form, potential energy. So as we've talked about, energy cannot be created or destroyed. It can only be converted from one form to the other. Even the example when we were raising the water up to the higher level, that was energy taken from the sun to change our energy of the water from one form to the potential form. So other examples include the bonds within pieces of wood have chemical potential energy, which can be released when you have a fire. It releases this chemical energy when it's burned, which becomes thermal energy, heat, and radiant energy, the light given off. So in this case, we would have our chemical energy, I'm just going to write CE, is being converted into thermal energy and radiant energy. Energy transformation equation. These equations show the different forms the energy takes as well as the order. So each form of energy is separated by an arrow. So for example, a microwave uses electrical energy to create radiant energy, microwaves, which is transformed into thermal energy in our food. So we have our electrical energy, arrow, radiant energy, arrow, thermal energy. So you try. With another person, come up with at least 3 examples of energy transformation and write the proper equation. If you don't have anyone nearby, just do it yourself. Choose examples that haven't already been discussed. And that concludes our lesson on energy and its different forms.